Hi, and welcome back to this third part of this webcast that deals with Windows Azure Storage. By now we have created a web role, and this web role adds data to a message queue and adds data to Windows Azure Table Storage. And the next job that we have to fulfill is implementing our worker process. The worker process monitors the Windows Azure queue and picks up messages, looks up the appropriate payload in the table store, and does the necessary processing. So, open the worker role, and before we do anything else, we have to add, oh no, I already added the necessary references. Well, that's nice. But what we need in the worker too is we need our helper class for the cloud storage connection, and we need our helper class that represents the schema in the table store. So what I do for sake of simplicity here, I say add existing item, and I say go one directory up, and here we have, here we have our web role, and we have order and cloud storage connection, and then I say add as link. So we just link these two files here into it, and now we can start implementing our worker. As you can see, a typical worker is an endless loop. It just sits there waiting for a job. And I have again my personal worker with queue snippet that I regularly use whenever I have to do something with workers and queues and all this stuff. And yep, we will fill this one out and go through it line by line. So the first thing that we need here is we need a reference to the queue that we want to listen to. So this one's easy. Our connection equals to new cloud storage connection. This is our helper class, the one that we added in the second part of this webcast, and then we say no, that's it. We don't say anything. We just change queue to connection dot queue dot order queue. Yeah. The first statement here looks into the order queue and gets a message. If no message is waiting inside the queue, it will receive a null pointer. So here we check if there is a message waiting for us. If getMessage has a message, well, it returns the message. This time span value here is very important. Maybe you guess that it is a kind of timeout or something. No, that's wrong. It is not a timeout value. This value is here for so-called poison messaging handling. Imagine the following situation. Imagine you receive a message. This message has something wrong in it. If you start processing it, it throws an exception. It tears your whole worker process down, and so we call such messages poison. And when your worker process gets down, Windows Azure will spin a new machine up for you, the worker process gets up again, and Windows Azure queues do something very special. They care for reappearance of messages that have been received by workers, but that have not been deleted by workers. And this is the time span that after which the message reappears on the queue. So after 50 seconds, the message has either to be deleted by the worker, if successfully processed, or Windows Azure cares for reappearance of the message automatically. So this one's very, very important. If we have a message, we have to get the message payload. So where do we get the order data from? In our case, the order data is of type order, and we have to get this message. We have to get this order data from anywhere, and therefore we need again our var context equal to connection dot table client dot get data service context. Yep, WCF data service context. We had exactly the same code a few minutes ago, and now we can issue a WCF data services query to query table store, and that's quite easy. So var message payload equals to context dot, oops, something is missing. What do we have here? Windows Azure Diagnostic Service Runtime Storage. Yeah. No, something's missing. I think I forgot system data. So I think I forgot this reference to, no. Okay, yeah, no problem. I think that's it. I forgot just reference. Reference to system.data.services.client. Add this one, and now, nope, still another instance of queue here. Yep, we need the queue from our connection object, and build started and build succeeded. That's one, fine. So back to where we have been here. Here we have to read the message payload from the table client, and we could do that. Message payload equals to context dot create query of order. Now we can say dot where order dot partition key equals to cloud storage connection dot, can you remember, order table name, and o dot row key equals to message. That's it. String. The message contains the GUID of the order, and the GUID of the order is the primary key in our table store. Last but not least, we need the as table service query of order here, and we say dot. Did I forget something? I forgot something here. Nope. And last but not least, we say single or default. Okay, this is the message payload. This is everything that we need to read data from table store. Try to build it. Build started. Build failed. Sorry, what does he need? Oh, of course, he needs the entity set name. Sorry, we know this one. He needs to know the table name, and here is the table name. Try to build it again. Build started, build progress, and build succeeded. Fine. If message payload is not null, so if the payload is if the system has been able to read the message payload from table store, we can process it. And now this one's easy because previously we have created this process order message and just pass message payload, the stuff that we read from table store. So go down to our process order. We copied that one from the web role when we were separating the logic into web and worker role. So say order payload, and that one's fine. We don't need to prepare here. Just say command.parameters 0 equals to order payload dot order date value here, and command dot parameters I cannot type anymore. Command dot parameters 1 dot value equals to order payload dot customer name, and command dot parameters and 2 dot value order payload dot amount. Fine. Command dot execute non-query. Processing done. Process order should work fine, and that's it. We receive the message here, get message. We get the message payload from table store. Here you see the WCF query behind the scenes. This is a this is a REST query, so our where clause will be encapsulated into a URI, and the system will respond with an atom pop message and all this stuff. It's completely hidden behind the scenes. We don't have to care about it if we don't want to. And then we process it by storing it into our database. An important thing is this one here. I told you a few minutes ago about the about the poisoned messages, and this is the handling of the poisoned messages. If the message could not be successfully processed, so for instance, if during the process order call an exception appears, this exception is caught here, and if the message has been dequeued more than 2 times, 0 and 1, it is deleted automatically. We have to delete the message also if we have successfully processed it. So in this case, we can say connection.order queue.delete message, and that's fine. And last but not least, we have to delete the message payload too. But the important thing is this one. Even if we didn't successfully handle the message, we have to delete the message because it is poisoned. If we try to handle it more than 2 times, we say no, we cannot handle this one, and in practice, of course, we have to do some error handling or logging or whatever. We will not do that in this simple example here. As I told you, we have to delete the message on the one hand, and we have to delete the payload on the other hand. Deleting the payload is quite simple. We can say connection dot table client dot delete context dot delete object, which one, the message payload, and we say context dot save changes with retries. We had this one before a few minutes ago. We called add object and not delete object, but deleting is very similar to adding the object. So I will set a breakpoint exactly here and hit F5 to start our application. And I think it will crash. I forgot something.